The first part of tonight's homework comes from page 186 and 87, and we are working numbers 31 through 35. Numbers 31 through 35, the directions say solve each equation, then check your solution. Number 31 looks like this. We have 4t minus 7 equals 5. Okay, we've talked about 4 steps for solving any equation that we need to solve. Step 1, we said, was to get rid of any parentheses that we see in the equation. There are no parentheses, so we don't need to worry about number 1. Number 2, we said that we're going to look at the left-hand side of the equation and the right-hand side of the equation to see if there are any like terms. There aren't in number 2. Number 3, we said that we are going to see if there is a variable term on both sides. We see 4t on the left, but there isn't a variable term over here on the right. So number 3 we don't need to do. Number 4, though, we said is to solve the two-step equation. Number 31 is just a two-step equation. We said we're always going to get rid of anything that is added to or subtracted from the variable. So the first step in number 31 is to get rid of the minus 7. Since we have minus 7, if we're wanting to get rid of that, we need to do the opposite of subtracting by 7. We need to add 7. If we add 7 to the left, we also need to add 7 to the right. If we subtract 7 and add 7, it's like we didn't add or subtract anything. So we just get rid of the minus 7. What we're left with on the left-hand side is 4t, and on the right-hand side we have 5 plus 7 is 12. At this point, it's a one-step equation. 4 times t equals 12. So since 4 times t equals 12, if we divide the left by 4 and if we divide the right by 4, we'll find out just what t is. 4 divided by 4 gives us 1, so we're left with 1 times t, or just t. On the right hand side, 12 divided by 4. When we divide those two, we get 3. So our solution is t equals 3. Well, we know that the solution of an equation is the value that makes the left hand side of the equation equal to the right hand side. So we can check that, and it does tell us to check it in our instructions. It says to check it, we need to take the original equation, and anywhere we see t, we're going to substitute 3 in. So instead of 4 times t, we're going to do 4 times 3. 4 times 3 minus 7, and we want to see if that equals 5. 4 times 3 is 12. 12 minus 7, when we continue to simplify that, is 5. So the left-hand side is 5, the right-hand side is 5. Since the left equals the right, we know we solved it correctly. So that's number 31. Be sure that you solve each of these and check. Alright, if we continue to look down, we'll work number 35 as well. 35 is 4d plus 5. It's 35. We have 4d plus 5 divided by 7. And on the right hand side we have equals 7. We've thought about these equations that have these big fractions as two separate smaller fractions. So the first step we've taken to solve these is to split it up. Instead of this entire fraction, we've rewritten it as 4d divided by 7 plus 5 over 7. Each part of the numerator is divided by 7. Alright, then we said that if we have the variable in our equation in the numerator of a fraction, we can really just bring the coefficient out in front, and instead of having this as being divided, we can have it multiplied by the coefficient. So 4/7 times d plus 5 over 7 equals 7. Alright, at that point, that's a two-step equation. Okay, we need to solve the two-step equation always by either adding or subtracting the number that is added or subtracted to the variable. So since 5/7 has been added to the variable, we need to subtract 5/7 from the left and subtract 5/7 from the right. So 5/7 minus 5/7 gives us 0. So on the left hand side of the equation we have 4/7 d. On the right hand side of the equation we need to subtract those. If we're not good at subtracting these, again, in your calculator, just enter 7 minus, and then in parentheses enter 5/7. Always put any fractions in parentheses in your calculator. Okay, so when we type that in, 7 minus parentheses 5 over 7, we're going to get a repeating decimal. We're not going to get a whole number. But if we change that to a fraction, we're going to get 44 sevenths. 44 sevenths. At this point, our equation is a one-step equation. We have 4 sevenths times d, so we need to divide the left by 4 sevenths, and we're going to need to divide the right by 4 sevenths. 4 sevenths divided by itself just gives us 1, so all we're left with on the left-hand side is d. On the left-hand side, sorry. On the right-hand side, we need to divide those two fractions. Again, if you're not good at dividing fractions, it's okay. Put each fraction in parentheses and then enter that in the calculator exactly as it appears. If we do that, if I do parentheses 44 over 7 divided by parentheses 4 over 7, we get 11. So D equals 11. So our solution on this problem, number 35, is 11. Keep in mind we can check that by taking 11 and putting it back in place of the variable in our original equation. So instead of 4 times d, we have 4 times 11 plus 5 divided by 7, and we want to see if that's equal to 7. Well, 4 times 11 is 44. 44 plus 5 is 49. So 49 divided by 7 equals 7. If we divide 49 by 7, we get 7 equals 7. So since the left equals the right, then we know we did it correctly. If it doesn't, then we know we need to go back and rework it. So that is number 35. Looking at the next section, we have 50 through 52. In these examples, we're doing the same thing. It says solve each equation, then check your solution. The only thing different about this section is that we're going to have the distributive property to deal with on 50 to 52. So I will show number 52. On 52, we have 3x minus 2 times x plus 3 equals x. Again, keep in mind all of the equations we've seen in class we can solve thinking about 4 steps. The first step we said is that we're going to get rid of any parentheses by using the distributive property. So when we distribute this 2 outside the parentheses, I have to treat that minus as a negative when I'm distributing it to each of these terms. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6, so I'm going to write that as minus 6. In front we have 3x, so 3x minus 2x minus 6 equals x. That's step 1, get rid of any parentheses using distributive property. The second step we talked about doing was to look on each side of the equal sign and see if there are any like terms. If there are, we need to combine those. Well, on the left we have 3x minus 2x. Well, 3x minus 2x, when we combine those, we just get 1x, or just x. We still have minus 6, so x minus 6 equals x. That's step 2, get rid of or combine any like terms on either side of the equal sign. Number 3, we said that if there are any variable terms, or if there are variable terms on both sides of the equal sign, we need to choose one of those to get rid of. Well, I'm going to get rid of the x on the left-hand side. The way we do that, if I want to get rid of the x, is I need to subtract x. If I subtract x from the left, I need to subtract x from the right also. X minus x gives us 0, so all we're left with on the left-hand side is negative 6. On the right-hand side, x minus x gives us 0. So we don't have anything left on the right-hand side of the equation. So if we don't have anything, I'm going to bring a 0 down. Alright, this is one of those special cases that we talked about where we don't have any variables at one point in the equation. We've worked this equation as far as we can and we get negative 6 equals 0. Since there are no variables, we know that there's not going to be just a single number that's our answer. Okay, so we said that anytime our variables cancel, we need to see if there's a true statement in the end or if there's a false statement. This equation says negative 6 is equal to 0. Well, we know that negative 6 is not equal to 0, so this is a false statement. So we know that our answer to this equation is no solution. That means that there is not a single number that you can put in for x in this equation that makes the left-hand side equal to the right-hand side. So our answer is simply no solution. That's number 52. The second part of our homework tonight is from page 175, and on these pages we're solving for an indicated variable. So this is confusing to a lot of people, but when we are solving for an indicated variable, that means that we are following all of those same procedures that we've taken to solve the other equations we've seen, but we're not necessarily just going to get a single number answer as our solution. We know that we have solved for the indicated variable when that variable is by itself on one side of the equal sign. So we worked numbers 4 through 6 from this page, so let's look at that. Number 4 on page 175 says 3x minus 4y. Equals 7. Okay, and the directions say solve for x. That means that we know that we have solved that equation when x is by itself. Well, since the 4y has been subtracted from the 3x, if we want to get rid of that, because our end goal is to get x by itself, then I need to add 4y to the left, I need to add 4y to the right. Minus 4y plus 4y. Those are inverse operations that give us 0. So on the left-hand side of the equation, what we have left is 3x. On the right-hand side of the equation, we have 7 plus 4y. Be careful here because a lot of people are going to be tempted to add those together. We can't combine these to get 11y or anything like that. 7 and 4y are not like terms, so they can't be added. So we'll just write it as 7 plus 4y. We still want to get x by itself, so we know to get x by itself, since x has been multiplied by 3, we need to divide the left by 3 and we need to divide the right by 3. 3 divided by 3 gives us 1, so we have 1 times x, or just x. And on the right hand side we have 7 plus 4y divided by 3. Well, there's nothing else that we can simplify that into, so that would be a possible answer. Another way that this might show up is x equals 7/3 plus 4y over 3. Okay, these two would be the same answer. So either of those would be fine. That's number 4. Numbers 5 and 6 are similar to those, so we'll look down at one from 11 through 18. Let's look at 13. Number 13 says y plus a divided by 3 equals c. And we are solving for y. That means we want to get y by itself on one side of the equal sign. We handle these equations a little bit differently than some people do, but the way we've talked about any of these big fractions where we have more than one term being divided by a single number is we've been splitting these up into 2 smaller fractions. So y divided by 3 and a divided by 3, since they're added in the numerator, we're going to add those fractions. Then we said that if we have a variable in the numerator of one of our fractions, we can bring the coefficient out in front. Well, the coefficient of these 2 terms is an implied 1. So we can think about y divided by 3 as 1/3 y and a divided by 3 as 1/3 a. We're wanting to get y by itself in this problem, so we want to subtract the 1/3 a from the left. If we subtract 1/3 a from the left, we also have to subtract 1/3 a from the right. 1/3 a minus 1/3 a gives us 0. So on the left hand side of the equation we have 1/3 y. On the right hand side of the equation we can't combine these terms because these aren't like terms. That means I can't subtract one from the other. So I'm just going to write that as c minus 1/3 a. The only other step that we need to take to finish solving this equation for y is we know that 1/3 y is 1/3 times y. So I'm going to divide the left by 1/3 and I'm going to divide the entire right by 1/3. 1/3 divided by itself cancels, and what we end up with on the left hand side is just y. On the right hand side, we have this entire fraction divided by 1/3. Well, I can split that up and think about it as c divided by 1/3 or minus 1/3 a divided by 1/3, and then we can simplify that. Well, c divided by 1/3, this is like having a 1 in front. So if I divide c by 1/3, I'm going to get, if I divide, 1 divided by 1/3, we're going to get 3. So 3c. If I divide 1/3 by 1/3, well, we know that anything divided by itself gives us 1. So we're just going to have 1a, which I can just write as minus a. So y equals 3c minus a would be our answer on number 13.